There are several possible reasons why your 3 kV single-phase transformers with a 277-volt primary and 120-volt secondary are outputting only 100 volts when the incoming voltage is 280 volts. Let's explore those reasons and how to address them. Firstly, consider the voltage drop in the primary circuit. The incoming voltage of 280 volts is slightly lower than the transformer's nameplate rating of 277 volts. Use a voltmeter to measure the voltage drop across the primary circuit from the utility grid to the transformer. A significant voltage drop here can lead to a lower secondary voltage output. Secondly, transformer saturation is a possibility. If the transformers are overloaded or the incoming voltage is consistently above 277 volts, the magnetic core can become saturated. This reduces the transformer's efficiency and lowers the secondary voltage. Thirdly, review the secondary wiring for errors. Ensure the secondary wires are correctly connected to the zone and X3 terminals as indicated in the nameplate. Confirm the ground wire is properly connected to the X3 terminal and the common ground bar. Make sure the black wire is connected to zone and the white wire to X3 to achieve a 120 volt output. Fourthly, transformer aging can play a role. Over time, transformers can experience a decline in efficiency. This can reduce the secondary voltage output, particularly when operating under load. Fifthly, consider load imbalance. If the load on the secondary side is imbalanced, meaning one phase carries more load than the others, it can cause the output voltage to be lower on the heavily loaded phase. Sixthly, measurement errors are a possibility. Ensure your voltmeter is accurate when measuring the secondary voltage. Verify the measurement points to ensure the voltmeter is connected across the appropriate terminals. Now, let's talk about recommended actions to take. Firstly, inspect the primary circuit. Check for voltage drop and ensure proper connections. Use a voltmeter to measure the voltage at different points in the circuit to identify any areas with significant voltage loss. Also, ensure all connections are tight and free of corrosion. Secondly, test for transformer saturation. Disconnect the load and measure the secondary voltage under no load conditions. If the voltage is significantly higher than 100 volts, it suggests saturation. Compare the no-load voltage to the transformer's nameplate rating. If it's close to 120 volts, the transformer may be operating normally. If it's still low, the transformer may be saturated or have other internal issues. Thirdly, verify secondary wiring. Confirm that the wires are connected correctly and that the ground connection is proper. Double-check that the black wire is connected to the zone terminal and the white wire is connected to the X3 terminal. Also, make sure the ground wire is securely connected to the X3 terminal and the common ground bar. A loose or incorrect wiring connection can cause a voltage drop and affect the output voltage. Finally, consider transformer replacement. If the transformers are old or have been operating under extreme conditions, consider replacing them with new ones. All transformers may have worn-out components or insulation, which can reduce their efficiency and output voltage. If you've tried all other troubleshooting steps and the output voltage is still low, replacing the transformers may be the best option. When choosing new transformers, make sure they meet your specific voltage and power requirements. Also, consider energy-efficient models that can help reduce energy consumption and save money over time. In addition to these possible reasons and recommended actions, there are a few other things to keep in mind. Firstly, check the transformer's nameplate for specific voltage and current ratings. Make sure the incoming voltage and load current are within the transformer's specified limits. Operating the transformer outside of its rated limits can cause damage and reduce its lifespan. Secondly, consider the ambient temperature. Transformers are designed to operate within a certain temperature range. High ambient temperatures can reduce the transformer's efficiency and output voltage. Make sure the transformers are properly ventilated and not exposed to excessive heat. Thirdly, check for any signs of damage or wear on the transformers. Look for cracks, leaks, or corrosion. If you see any damage, the transformer may need to be repaired or replaced. Regular maintenance and inspection can help identify potential problems early on and prevent costly repairs. Remember, working with electrical equipment can be dangerous. If you're not comfortable performing these troubleshooting steps yourself, consult a qualified electrician. An electrician can safely diagnose the problem and recommend the best solution. In summary, several factors can cause a lower secondary voltage output from your transformers, including voltage drop in the primary circuit, transformer saturation, secondary wiring errors, transformer aging, load imbalance, and measurement errors. By inspecting the primary circuit, testing for transformer saturation, verifying secondary wiring, and considering transformer replacement, you can identify and address the underlying cause of the problem. Always remember to prioritize safety and consult a qualified electrician if you're not comfortable working with electrical equipment. Regularly check all the connections, look for corrosion, and consider replacing the transformers if they are aged. You may also want to check the loading and try to balance it to bring the voltage to the optimal level. Ensure that you have a stable power supply, and if you do not, you may want to consult the utility to improve the power supply to your location. Ultimately, the goal is to provide safe and reliable electrical service to all of your devices. Remember to turn off power during any inspection.